All right, we are topic 3, lesson 4, and it is rigid motions. That is moving in two types of things. Like I'm gonna rotate and then I'm gonna reflect. I'm gonna translate and then I'm gonna rotate. So 2 things in a row. It's basically a composition, you guys. Basically a composition. So what I have up here is a theorem, and it says that if I have QRST, and then I go to QRST prime, look what happened. Look how the R's and the S's and the T's. So what happened right here? Did I rotate? Did I translate? Did I reflect? From original pre-image to image prime. Anybody volunteer?
That's reflect, right?
I reflected. So I can even draw my line of reflection evenly spaced between like point R and R prime. So you basically count how many spaces between R and R prime, and your line of reflection goes directly in the middle. So I reflected first. Then I went from prime to double prime. How did I get QRST prime to QRST double prime? How did I get from here to here? I like hands, not yelling out. Kenneth.
It was rotated.
Yep, good, rotated. All right, so nice. Therefore, the first movement, the reflection, and then the rotation, composition is called a rigid motion, a rigid motion. So here we've got T and S. Here's the first movement, T, right? And there's my second movement, S. So S to T, first movement, second movement. So basically, I'm going to write down in words, using all words only, what I did. And here we go. Let's actually, I want this to be like the whole thing. Ah, so much better. Okay, paragraph proof, sentences. T and S are rigid motions. So I made a movement, T and S are rigid motions. Since T and S are rigid motions, I can then say that like the side lengths are the same, right? I didn't change the look of, I could have turned it and reflected it, but it's not like I made this, the L shape longer or shorter, or the angle, did the angle increase or decrease? No, it's still an obtuse angle there. So I'm gonna say that like the line PQ is the same as P prime, Q prime. These lines, this line is the same as this line, right? And I also know that the P prime, Q prime, this line is the same as this line. P double prime, Q double prime. The same length. So I know that it kept its shape, right? Now I want to talk about the angles. The angles didn't change. Like the measure of angle PQR is equal to the measure of angle P prime, Q prime, R prime. So this angle right here is the same as this angle. They're both obtuse. If I had, you know, a protractor, I could measure it out. Then, what else? Oh, well, this angle right here, Q prime, that's the same as this one here too, because again, I didn't change the overall look of the image. Measure of angle P prime, Q prime, R prime is the same as the measure of angle P double prime, Q double prime, R double prime. So the angles were the same, and I did that in purple. You saw that, so it's purple, right?
Colby, you did not log me out again. Stop.
Have your self on mute, guys. If this is equal to this and this is equal to this, then I can say that they're all equal to each other. Original equals the double prime, or the angle. This angle equals this angle, and this angle equals this angle. So the first angle equals the third angle. It's proving that I just made movements. So by the transitive property, all the movements were the same and all the images are equal, which means that I made a rigid motion. PQ equals P double prime Q double prime. The first one equals the third one, the line segment. And the angles, the first angle equals the third angle. PQR, measure of angle PQR, is equal to the measure of angle P double prime Q double prime R double prime. The first equals the third. Logan.
Why is angle PQ equal to angle PQ P double prime?
Because I had this first angle same as this angle. They didn't change measurement. And this angle was the same as this angle meant. All three of the angles are exactly the same size. They're just like turned, right? So the transitive property says, if this angle equals this angle and this angle equals this angle, then the first equals the third. And that's what this is, the first original, and here's my double prime.
Oh, okay, thank you.
The only thing I didn't talk about, which I could have, was QR. I could have talked about QR, but I didn't. It's just a lot. Okay, now I want to look, we're not going to do the workbook example. Now I want to look at this bottom shape, and I want you to stare at it for a second, and I want you to tell me a rigid motion means two movements. Can you figure out a way that I made two movements, that my pre-image became my image? How did my pre-image become my image? It did. My pre-image became my image. And I just kind of want to figure out what was the movement that was made. Does anybody have any thoughts they want to share? Connor.
Wait, you're talking about like what the movement was, right?
Yeah, there's two movements. Two things happened.
It reflected, right?
It did reflect.
Like, it reflected.
You want to reflect first? Let's reflect first. Now, I need to look and see how far apart these images are to figure out what's the line of reflection. Because it did change and it did reflect. But the only way I'm going to know what the line of reflection is to know where's exactly in the middle of these two lines, of these two triangles. These two triangles are here and here. They're spacing of 1, 2, 3, 4 apart, 4 spacings apart, right? So if there's 4 spacings apart, what's in the middle of 4? How many spaces are in the middle of 4 spaces? So that would be like here. My line of reflection is x equals -1. So first, we want to reflect. Now remember, compositions, I put my second, in the second position, what happened first? Remember that? Okay, so when I reflected, I get this triangle right here. Now, how do I get pencil triangle to be down here? Ryan.
You translate it Down 5.
Translate it means, you know, shifting it down 5. So you can use a corner to guide you. Ready? This is the bottom corner. This is C. And this is A. And this is B. I'm going to shift 1. I got to get C to be in the same position as C prime. 1, 2, 3, 4, 5 down. That looks like this, guys. Nothing to the left or right. 5 down. That's the second movement I made. Because the student that I chose decided that we would reflect first, I reflected first. But could I have translated 5 down first? Could I have done this? And then could I have done green, translate down 5 and then reflected? Does that give me the same result?
Yes.
Yes, it does. So this can be reversed. You can translate first and then reflect. You can reflect first and then translate. The question that it asks us on the next page says, does a reflection, a translation, or a rotation map the first triangle, the pre-image to the image? So it's asking, which one did I do? Did I reflect, did I rotate, or did I translate? So I'm going to turn the page. We're going to answer that question. It's asking, how did I get there? Which one did I do? Which one did I do? Oh, I didn't do just one. Not one movement was made. It was a composition. 2 movements, right? So of 2 motions. What composition of 2 rigid motions maps? Oh, that's what we're talking about. A, B, C to A prime, B prime, C prime. It was this. We did translate, reflect over x equals -1. Remember, it can be reversed. For this example, I could have reversed it. So the composition of a reflection followed by a translation is called a glide reflection. Sorry, let me move up. Composition of a reflection followed by a translation is called a glide reflection. So this is actually where we're going to stop for notes for today. I want to talk to you about your homework. Your homework page is this. Please notice that on Google Classroom, I already put which problems you're supposed to do. Okay, day 1, that's today, is just 1 through 7 and 15 through 20. So,
Miss Grant,
yeah.
can you go back to the other one and up a little bit?
This?
Yeah.
Well, you helped me realize I made a typo. So on your homework numbers 1, 2, and 3, you have to decide which rigid motion was done. I'm going to go back to the homework paper.
All right, thank you.
Yeah. Which was done? Which was rotated about P and then reflected? Okay. I'm going from 1 to 2 to 3, right? Down here, if I go from triangle ABC to triangle A prime, B prime, C prime, is it a reflection, a rotation, or a translation? And then the amount means like name the the movement? Like, what is it that I did? I reflected over the x-axis. I translated 5 units down. Okay. So you say what it is, what did I do, which one, then name it, like using the notation that we've learned. 6 and 7 is basically if I go from A and I translate it twice, what's my end result ordered pair? So these are ordered pair answers. What did I do? Okay. 15 through 20, a glide reflection. Remember, a glide reflection means, did I translate and then reflect? Oh, sorry, you can't see it. Did I translate and then reflect? Or did I reflect, then translate? Capital T. Okay, so you have to look at over that line and decide, is it possible for me to do that?
Wait, so real quickly, a glide is when it's reflect and translate?
Uh-huh.
Okay.
Combination, composition. Okay, the chat, I'm gonna stop recording, but the chat, guys, remember, I don't know what you're saying. So, okay, I'm gonna end this.